In this video, I'm going to show you how to monitor the drag coefficient alongside the residuals as the iterations proceed so that you can keep track of iterative convergence or equivalently the linearization error. These steps are being shown in version 18.2 since they are different from the steps in version 16. So this is a newer video. Go to Fluent and highlight report definitions and double click on it, and under new report, select force report drag, and I'll give it a suitable name. I'll say CD for drag coefficient. By default it's calculating the coefficient rather than the force, so that's right, except that I need to give it the right reference values, which we'll do in a little bit. And I want the integration of the surface forces over the entity pipe wall, which is this surface in this particular figure. And also the direction of my force is in the axial direction. So as shown in this figure, and the axial direction is x in Fluent, so x is 1 and y is 0, so that specifies the axial direction. And I'll say create report to file, so it'll write the data to a file, and it'll also create a plot if I select this, and we'll look at the plot. And I'll also say print to console, and I'll say OK and close out of here. And then, so now it has all the information that it needs to calculate the drag, and let us give it the denominator so that it can non-dimensionalize the drag to get the drag coefficient. And in the denominator, we need to give the three reference values, as we saw: the area, the density, and velocity. So let's do that. I'll double click on reference values. The reference area is 1.885. The reference density is 1, and the reference velocity is 1. Okay, so what I have here matches this, so that looks good. And what I'll do is I'll reinitialize the solution. So I'll go double click on initialization, and I'll say initialize, and then I'll say run calculation. You might get a pop-up saying, do you want to discard existing data, and you can say yes there. And then I'll go under run calculation, and I'll say calculate. And so now you see that in addition to the residuals, you also have a plot of the drag coefficient because we enabled the plot. And from this plot, it looks like the drag coefficient is not changing very much at this point in the iterations, which is what we'd like to see. Though we might want to zoom in over here by adjusting these axes, and I won't do that here. And then if I look at the console window, because we said print to console, the values are printed here, and it looks like the drag coefficient is not changing for many iterations, and the value is around 0.17, which is close to the skin friction coefficient in the fully developed region of 0.16. So that's heartening. In fact, initially when I was trying this out, I didn't give the right reference values, and I saw that my values were quite a bit off from 0.16, and so that was a way for me to check and fix what I had. So that's heartening. And then if I want to look at the file where the data is stored, you see that under report files, I see it has this object here. And if I double click on that, it shows me the file name, and it also shows me the path where that file is stored. So it turns out, if I go to the folder, and if I go to, so this is my working folder in this case. Actually, this is my working folder, ANSYS files, and then this is my project name. This is my project name, and this is the associated folder. And if I go into that folder and go under DP0, FFF Fluent, you have to kind of dig in, and you see this file over here. It's a text file. that you should be able to read into WordPad, and that's where that data resides. So you can dig in, you have to dig in, and you can find the file where that data is stored in case you want it in the future. So that shows you how to monitor the drag coefficient in version 18.2.